not even though they aren't on my book. Alright, the derivative and tangent line problem. Question. Did we talk about the tangent line problem at the beginning of the year?
Not really.
Yes, we did. How many big problems are there to calculus? Two. There's the tangent line problem. Remember you guys drew the secant lines and it got really hard, but you were able to see the slopes approaching the tangent line slope? Okay, and what was the second big problem in calculus? The area problem. You put little rectangles under and you had to think about what the areas would be and add them all up and see if they approach, right? Okay. We are not going to talk about area until second semester. But we are going to talk about tangent line for quite a bit. And not just the tangent line problem, but all of its applications. And the snazzy thing is, there is a special word, a term, a vocabulary, that refers to the slope of the tangent line, which is synonymous with the slope of the graph at one point, which is applied in that you were able to find the rate at an instant. And that one word is the derivative. Ask any calculus kid what's something they learned, they say, well, something to do with derivatives. And hopefully they also remember integrals. But if nothing else, you should remember derivatives. The derivative. The derivative is, well, maybe I should say, if I'm talking about slope singular, I should say a derivative. A derivative is a slope of a tangent line, a slope of the graph at one point, or an instantaneous rate. So technically, a derivative, add a little in there, a lowercase one. No, a derivative. A derivative. Because a derivative could just be one number, one slope at one point. And I think if I remember from your guys' exploration, what the slope of the tangent line like 2? Yeah. Weren't you approaching 2? That's the example of one derivative. It was a derivative. But if I'm talking about the derivative, I'm probably talking about the derivative function. The derivative can be an equation. And if the derivative is an equation, it's representative of all the different slopes at all the different points of all the different tangent lines of a function, of a curve, of a graph. Okay.
Yes, it is.
The page before was a description of a derivative. Kind of like a description of continuous is, I know it's a struggle, is a graph with no holes, jumps, breaks, vertical asymptotes, right? That's a description of continuous, but the struggle is how do you guys put the description in your forever card for continuous?
No.
I had to put the definition for continuous in your forever card. And once again, it was an informal definition. It wasn't the crazy mathematical proof as to why and how it works definition, but it is a definition. So continuous. Description. A graph with no holes, jumps, breaks, vertical asymptotes. But the definition is f of c exists, the limit of x approaches c of f of x exists, and f of c coincides or equals the limit of x approaches c of f of x. All three conditions must be true. Description of derivative. Slope of a tangent line. Slope at a point. Slope of a curve at a point. Instantaneous rate. All of those are descriptions or applications of derivatives, but the definition of a derivative. From our group activity at the beginning of the year, we talked about how we need to find slopes between secant lines, and we need to make the separation or the distance from the one x value to the other x value. We need to make that distance get smaller and smaller and smaller. We symbolize that by delta x approaching 0. And we also talked about the difference quotient earlier this year. On top, it's just a y2 minus a y1. It's kind of crazy notation. But it is a y that is a little bit away from the x minus the y at the x all over change in x. Remember, slope of any lines is just rise over run. Change in y over change in x. So on top I have y's. On top I have my difference quotient. Sorry, on top I have my change in f of x's. F of plus delta x minus f of x. On bottom, I have my delta x. Did you guys see one of these in homework? Something with a delta x? Yeah. It was kind of weird because you didn't know what to do with it, and I tell you that x and delta x are different. You don't get to put it. Yeah, you had to like FOIL stuff and try to combine like terms, and you were simplifying. However, there is another. What's going on there? The delta is on top of the x. He's not supposed to be here.
Delta.
Yeah, that's what delta x
That was
Say, I wanted x
There he is. There he is. There is another way of writing the definition of the derivative, and some of you will like it better, and actually it was the bonus on your last test. Because another way of writing it is f prime of x equals the limit as, some of you don't like that delta x, it's confusing in your brain. So if you let a letter in the commonly used one is h, if you let h equal delta x, you can go ahead and change it and say the limit as h approaches 0 of f of x plus h minus f of x all over h. It's the exact same thing. You're just taking a step back from the definition.
No.
Yep. The bonus, if you solved it correctly, you were taking the derivative of the function that you were given by plugging into this difference quotient and solving. Which is why the final answer to the bonus was 8x minus 3. Well,
whoops.
this is forever number.
5.
Okay, dilemma.
X minus 3.
What?
Sure, it wasn't 4x minus 3.
At least period 6 was 8x minus 3. That's the one that's in my head right now. I'm getting out a yellow box.
Oh boy.
Boop. He's so excited. The title is Definition of Derivative. Now pause. You get to choose what form you like. You have to be able to recognize either. And you have to write both on your forever card. But if it's ever a forever quiz and the question is give the definition of derivative, you just either need to state this one or this one, which you must, if you like the h's, you must say let h equal delta x. So if it was a forever quiz, you can either state all of this and that's enough, or you could put this one in that place and state it, but you must say let h equal delta x. This is forever number, hold on. 6. I know.
You want to make it 7?
I know.
Choose now or
I'm
forever.
debating. No, click. The trouble is there's another card I want to add to. We have 49 as of last year, but I have 2 different cards I want to put in, so that's what's going on.
Only one. No, because if she doesn't do it now, it'll be all out of order and wrong.
Alright, I want you guys to go back to horizontal asymptotes. I want you to go back to horizontal asymptotes in your notes. What section was that, guys?
1.6, I think.
Go to 1.6. Table of contents. Use it or just look back. Go to 1.6. The definition of derivative is going to be forever number 7. Because we are making forever number 6 to be the degree tests. I shouldn't need to, and yet year after year I wish I had. So. Okay. You guys have it filled out because you watched the video and I wasn't here, true? Okay. This is going to be forever number 6. Forever number 5 was intermediate value theorem, right?
On the degree test section?
Wait, so which one is that's the forever card?
This is the forever card.
Yeah.
Okay, we're going to call it the horizontal asymptote card. The horizontal asymptote card, you find the horizontal approaching by having x approach negative infinity, taking the limit to negative infinity, taking the limit to positive infinity. How do you take limits as x goes to infinity? Degree test. Degree test. I'm also going to say check the sign. So how do you put two things? I mean, it's basically all of section 1.6 in the card, right? Because either bottom wins. If the bottom wins, what is my horizontal asymptote or what is my limit? Top wins. Yep. What was the question mark for? Check the sign. You have to check plus or minus infinity. It's only going to be one as you go one direction. The letter C. Tie, right? Is the tie? The limit is the ratio of the leading coefficients. The question. Coefficients, I just put COEFF. Why am I doing a question mark there as well? Now, usually you don't have to check the sign, except I'm going to put check the sign because, do you remember which tricky ones we have to watch out for, which is why I just square root absolute values, and there's technically a third. Exponentials. Exponentials. Logarithms can't ever go to negative infinity unless they've been flipped. So you would only worry about positive infinity. The exponentials, positive infinity, they increase and they're super strong. Negative infinity, exponentials go to 0 and they're super weak.
Yeah.
So this is forever number 6. Does that make sense? This is forever number 6. Remember our last quiz after intermediate value term. I didn't cram this one in because I didn't want you guys to stress about a new card right before the quiz.
So then what's the degree?
These are the degree tests. These ones. So I just summarized the degree test. If you want more detail, you can actually take it from your notes. It's up to you what you put down. But I would say that should be enough because we have a top and we have a bottom and we're doing the test. Does that make sense? Okay. If we don't have a top or bottom, we're getting a top or bottom. But we'll see that as AP practice gets harder. So that was forever number 6. You guys got it okay? I'm going back to forever number 7 then. All right, forever number 7. Once again, if I was to ask you, you would only need to put one of those formulas down on the card, but if you like the H one, you must say let H equal delta X. Now, kiddos, to find a derivative then at this level, all we're going to be doing is finding a special limit. To be finding a derivative, all we're going to be doing is finding a special limit. So, whoo! Can't use the power rule. Everyone has seen it though, because you did this under packet. But we're not using that. Those are shortcuts to the process that usually work. Even the BC kids this year saw the shortcuts only usually work. There were a couple problems they had where even they had to go back to the definition again. So we're going to start with the definition. And as we do the definition, maybe we'll see why the shortcut rules are what they are. And to be honest, for number 2, most of you are not prepared to take a derivative with a shortcut rule for number 2. Even though you saw the chain rule during the summer, that doesn't mean you totally understand the chain rule. I said most. Number 1. Okay. What do you guys like? The one with the delta X or the one with the H better?
Sure. Yeah, so help us, man.
Okay, I've heard it both ways. So let's do the easier one with delta X. Let's do the harder one with H. Sound good? So the easier one we're going to use, P.S. Whenever you write this limit, you need to think f prime equals. You need to think f prime equals the limit. This delta x goes to 0. I can actually find it. Okay, how do we actually plug in? We have practiced function notation, so I'm just going to go for it. But some of you might need to go slower. So if your brain does not totally understand where I'm getting all of these pieces, please come in, let me get a whiteboard, and let me show you how your brain needs to process it. But otherwise, okay, f of x. I have arguments inside the function, right? As I'm explaining to pre-cal currently, or in this chapter, whatever goes in these parentheses is not f times, it's f of, and that needs to go inside each of the inputs, each of the fields in my formula. So when I have f of x plus delta x, I have 5 times somebody squared minus 7 times somebody plus 3. To get my, just the first part, f of x plus delta x. I take f's formula, I leave spaces where the inputs are and say, okay, what's supposed to go in there now? X plus delta x. It could be x plus h or x plus delta x. I just decided to do one of each. You just have to do the whole little like, let h equal delta x. That's all you have to do. So I'm going to use h in the second example. I'm just using delta x right this second. Now, what part of the formula did I just do? This part. But what do I still need to do? The minus, and I still need that part. Who is f of x? So technically, this is my f of x plus delta x. That's the first part, minus. Here's my f of x. That's the second part. Now what do I need? Is this kind of like the bonus, but maybe just a little bit harder? The name of the game is, oh, it's a limit! Oh, I put h. That's what you did. Okay, so I started and then I changed my mind. I apologize. Doesn't make sense with an h if I'm not writing h's. If I was to plug in 0 right now, isn't that just going to be 5x squared? If I was to plug in 0 here, isn't that just minus 7x? And then 3 is 3. But what happens if I have 5x squared minus 5x squared, or negative 7x plus 7x, or 3 minus 3?
Yeah, they cancel.
0 over 0. Keep going. But wouldn't you have guessed we needed to keep going anyway? I mean, let's be honest, right? Wouldn't you have guessed that we need to simplify?
Probably.
So how do we simplify? Without killing puppies or seals.
What?
Killing puppies says, be super careful with the square. Killing seals says, be super careful anytime you have to distribute into a function. Really quickly off to the side, just to save on space. So if you guys notice, you have to write this twice, it's really a pain. Are you guys okay with me making the jump that x plus delta x squared is spoiling it out? X squared plus 2x delta x plus delta x squared. Are you okay with that? As you guys are writing and getting ready, remember, x plus delta x squared is the same thing as x. True? That's how we don't kill puppies. Think about it as it times itself. First, outer, inner, last. Yeah. I just spoiled it. So I have x and delta x, and I have delta x and x. They're the same guy. So 1 plus 1 is 2. that okay? So I'm going to take that, and what am I going to multiply all of those pieces by? Which is why I'm going to have 5x squared. 5 times 2 would be 10, right? I think that's where you made your mistake.
Yeah, I forgot
To double it.
Like it did it this time.
And then 5 times the other. Okay. Got that guy. Do I need to distribute my -7 now? I'm going to have -7x. -7 delta x. And I have a +3. But is it?
I mean,
Just algebra.
It's
It's a lot. It's a lot. But you can like shock the socks off some poor little kid and look at my problem. They're like, "Ah." Distribute the negative. Don't kill a seal. You gotta earn the right to go fast.
Because you bring down the two.
What are you hoping
Canceling.
everything can do? With
It's a bunch of
polynomials, no
themselves.
matter
It's
how
a
messy it is, it ends up nice because everything without a delta x, if you didn't kill any seals, should cancel. And the only parts left should all have a common delta x. Because a 0 over 0, the only denominator is delta x, so somehow the top must have delta x. Right? Pull out that delta x. You have 10x plus 5 delta x minus 7. What happens to that delta x? Same thing that should happen with the h if you that reduces away. In a limit, when I cancel out the whole, how do I finish the problem?
Plug it in.
Plug in 0.
Plug in 0 for only who? Delta x. So 10x stays. There's no delta x. 5 times 0 is gone. Minus 7. At this point, if you remember the power rule from the summer packet, you could check with the power rule. Okay.
Wait.
Hold on.
I don't know what it was.
Yeah, it's a minus. The other one was a plus, but it canceled out with the minus. Go ahead, Tyler.
Yeah, are we gonna learn the problem?
Oh,
for
yeah, of
this
course we
section?
are, but not for this section.
So, but for the test, do we have to write all this crap?
Yes,
out?
if I say solve with the definition.
And this was you last year. Didn't memorize this and did it. You thought of it. You knocked it off because you didn't know how to do it.
I didn't
Where know how to do it
Tell us how
quicker
you
than
really
you.
feel.
I didn't remember that.
Rose? Oh, brother Rose. That was good.
I'm good for it. I'm good for this.
He's turning red though, it's okay. How do we check the power rule though, Tyler?
3's gone. You move the 1 down to 7, and it becomes -7. X to the 0 is 1, and then you bring the 2 down, and it's 10 times x. Yeah, so it's 10x.
Remember power rule? You pop down the power, the 2 comes down. 2 times 5 would be 10. And you take the power down 1. So 2 minus 1 is 1 fewer. Pop down the power of 1. 1 times 7 is 7. Reduce the power of x, which would now be x to the 0. And if we wanted to, we could have this be x to the 0, pop down the 0, and the constant. We're going to learn the shortcut way. We're going to get really good at the shortcut way. For right now, if you remember from the summer packet, you can check with the shortcut. Okay? Once again, this is only if you remember the power rule from the summer packet. And if you want to remember the power rule from the summer packet, can't you go back on the videos and watch the power rule again? And it'll show how the power pops down. Number 2, probably the last problem we'll get to today, and that's okay because we're only starting 2-1. Ah, that's why I tried to make sure that you could start it.
It was like 4 problems.
I actually don't remember how many problems there are. Kiddos, real quick, do you know how Google Drive doesn't always update so hot?
Yeah.
So if you don't see the new homework, send me a quick email and I'll send you a link to the homework sheets. Because sometimes it takes Google Drive a while to update and I haven't gotten it in there yet, so my fear is that it's not going to show up for you guys until who knows when. Tyler. We could, but technically quotient rule is probably not a good way to solve this. Even though it's a quotient. I would do 2 times 3x minus 1 to the negative 1. Okay, f prime of x equals. I'm going to try to use the h this time. Because for some of you, the h makes things a lot easier. So I'm going to say let h equal delta x. So I'm not taking away from the definition at all. I'm just making it look nicer to me. My first step is, guys, couldn't I automatically just do this? Isn't it f of x plus h minus f of x all over h? I know what I'm doing, like what I'm plugging into. F of x is easy because he's chilling, he's right there. And there he is. That's my f of x, but I also need my f of x plus h, which means I take f of x, and the only thing that changes is the x becomes an x plus h. So, my formula is f prime equals, just remember what I'm plugging into, the limit as h approaches 0 of f of x plus h minus f of x. Does that make sense? So I took f of x in this spot, took f of x and plugged in x plus h. Good. Yeah, it's easy to do until you get it solid. Woo! Did anybody figure out this is 0 over 0? Keep going. So if I plug in 0, they're the same thing.
Yeah, I need that.
So what are we gonna do?
Multiply by the conjugate?
Not the conjugate.
The rational?
Simplify the complex fractions. Simplify the complex
3x
fraction.
plus h minus 1 times 3x
Oh, on top
minus
of
1 on both the top and the bottom. Oh my goodness.
Okay. She gonna be hard. She's ready to argue.
I gave you a hard one. First one was an easy one.
This is not even hard.
Well, but I'm simplifying. Wait. Aren't I just simplifying the complex fraction? Just simplifying the complex fraction. I know, but it's a summer packet technically. I'm multiplying top and bottom by both denominators, like I did with the summer packet. So when I multiply in, yeah, hopefully you guys have the easier problems in your mind. So when you bring this in, one's going to cancel on that one, the other one's going to cancel on this one. So I'm going to have 2 times the one that doesn't cancel on the first, which is 3x minus 1, minus 2 times the other one. You guys can back it up, that's okay. I'm just going to write this down. Guess what happens when you plug in?
Well, actually,
0 over 0, keep going by multiplying by the conjugate. I gave you a really hard one. We're going to see how to do this one tomorrow. The long story short of this problem is, there has to be a better way. And there is, it just takes work to get there. They're called the shortcut rules, and they're awesome, and we're almost there after the next section. Alright, kiddos, start over tonight, take stuff, come back tomorrow, we'll go over what you stuff.
Is the chain rule, is it f prime g of x minus g of x?
Prime, g, prime.
Times g prime of x?
Outer derivative, keep the inner times the inner.
So is the,
Yeah, you could have the x. Yeah, I can tell you how to do it. Probably not enough time. Lunchtime. We can do lunchtime. It shouldn't take long shot. I just need to sit down and show you what I gave directions and somehow you didn't understand. So we can talk about that.
is the outer 2x and the inner was, you said was,
The outer is maybe 1/2 hour.
outer, okay.
So going down negative 1 plus 1. Here is the exponential.
Oh, okay.
Good job, bud. So, test today?
Yes, after school.
Perfect.